Good morning. Today we're going to continue talking about line plots. And in today's lesson, we're going to look at line plots that use fractions for their data points. So we're going to start by looking at an example and creating our own line plot. So let's pretend that in a science class, you were asked to measure 10 different insects in inches and find out their different lengths. So if we listed those different lengths above here, okay, you'll see that they are all less than an inch. So they're fractional pieces of an inch, 3/8 of an inch, 1/8 of an inch, 4/8 of an inch, etc. Okay, so to create our line plot, first thing you're going to do is you're going to draw a straight line with 2 arrows on the end. And it's important, try to use a ruler, okay, when you create it so that you keep it as a straight line, okay? Then you're going to want to label, okay, the line plot down here. This axis here is going to show you the lengths of the insects in inches. Okay, now that you've labeled that, you want to also create spacing that's pretty even. Any kind of graph that you're doing, you always want to make sure that your different data points are equally spaced apart. So I'm going to look up here at my data, and I see that my lowest point here is 1/8 of an inch, and the highest that it goes up to is 7/8 of an inch. Okay, so that means that my data must range between 1/8 of an inch and 7/8 of an inch. So I'm going to start down here, and I'm going to label this as 1/8 of an inch. Now, I can see that I don't have any data points that are at 2/8 of an inch. Okay, but I'm still going to include that because you want to make sure that your data is evenly spaced. If you went from 1/8 right to 3/8, it wouldn't show you then that there are no insects with 2/8. So you need that data to be there. So now I'm putting my next data point as 2/8, okay, 3/8, and I'm just going to number it up, 4/8, okay, 5/8, 6/8, 7/8, and that is my highest, okay, but sometimes I like to go over 1, and that is 8/8 or 1 whole. Okay, so now I have a spot for all of the different data points, and I've made sure that they're all evenly spaced apart. So they're all 1/8 of an inch apart. Okay, my next thing then is to decide how many X's go above each of the data points. So I'm going to start down here at 1/8 of an inch, and I'll say, okay, at my 1/8 of an inch, I can see I have this data point here. So make sure that as you draw your X, you are marking it off. I usually draw a little line across. So I have 1/8 of an inch listed here. I have another data point of an inch. I have a third of an inch. Okay, so there are my 3 data points. Okay, for 2/8 of an inch, like we said, there are none. Okay, but that doesn't mean that that's not important, because it's important to see in your data that there is no 2/8 as a measurement. So I'm going to move on then to 3/8 of an inch. So 3/8 of an inch, I can see I have 1 here. Okay, and I look across all my other data points, and that's it. Okay, 4/8 of an inch, I have 1 right here, X, and another. Best you can to keep your X's fairly sizing. You need a large one, or it kind of throws your graph off. Okay. My next one now, 5/8 of an inch. You can see I have measured eighths, but it's important that we have that. One is 6/8 of an inch, and I have 1 that measured 6/8 of an inch. Cross that out, and I have 3 that measured 7/8 of an inch. Okay, so now that I have all this data plotted out, I can see just like, okay, range from 1/8 of an inch being the smallest to 7 being the largest. Okay, question 1/8 and 7/8 of an inch the most often. Okay, how many more of an inch? And you would say 2. Okay, way. So now you have all your data. Like this. Now we're going to look at a couple of examples and just kind of interpret what it means. So the example here says, Donna goes jog every morning. The line plot below shows the number of hours jog. So what you want to do now shows me the number of hours for 5 days. Hour. And we're going to take 1/4 of an hour. Okay, so you can see each we have 1/4, 2/4, and there's a whole. Okay? And if I even read the question, just send it. Where did she go? On no days did she go? She 2/4 of a mile. 2 3/4 of a mile, and she 1 whole mile. Okay? So the question down here is how many hours jog for 5 days? These were, sorry, hour plus 2/4 plus 3/4 plus 3. Right? So I have one whole, but 2/4 and 2/4 gives me up to 2 wholes. Okay. Another 3/4, and that adds up to 6/4. So these all I have 1 whole here. Okay. I have here 6 is the same as 1 and 2/4. Okay. And here I have 4/4, which is the same as 1. And if I put those together, 1 and so she jogged for a total and 2/4 hours. 3 hours. Okay. More example. It's sorting leftover each piece of yard and make a lot of how many pieces she had. And again, here it's labeled. This axis here is telling us the fabric length in yards and in fractional parts. 2/8 of a yard, 3/8 of a yard, and so on. Okay. And now they say, how much longer was the longest piece of fabric than the shortest piece? The longest piece of fabric, even though the plot goes up to the whole yard, no longer says the longest piece of fabric is 8 of a yard. The longest piece is 8 yards. It does go down to 0, but there's none that were 0 and none that were 1/8 of a yard. The shortest piece is 2/8 of a yard. Okay. And so I find the difference between the longest and the shortest. So how much are we going to do 6 of a yard minus 8, and that leaves with 4, okay, of a yard difference. They were a half a yard if you look at that difference. Okay. When you are just labeling your so that if you're looking at fractions that are given in sixths, each one should be measuring 1/6 apart. If you're looking at fraction fourths, each one is 1/4 apart, and so on. And make sure that you are drawing a line on the end, and be careful how you make your X's. Okay. So good luck today. You're going to complete the activity in which you're given data and you're going to do just like this. You can do it on any plain piece of paper. You're going to create your own line plot with that. Okay, have a good day.